Hello people, how are you? Today I'm going to teach you about ECG Basics. Okay, I have started making an ECG class in which I will slowly go through all the basics of ECG and how to interpret it. So for today we'll see how is lead placement and how does an hexaaxial system works in an ECG, what is the ECG paper, what is its composition, what are its parts, and what is a systematic approach to reading an ECG. So without further ado, let's move forward. Okay, as you already know, there are like 12 leads in an ECG. One is placed over here, right arm, right leg, left leg. These are called limb leads. Then there are like 6 test leads. Now you must be thinking that there are only these leads, 1, 2, 3, 4, 5, and 4 of these limb leads. One is V6, it's shown over here. So these are only 10. How come you say that there are 12 leads in an ECG? I'll give you that answer in a short while. For now, what we need to know is that we place these leads according to this. First of all, one is on the right arm, one is on the left arm, right leg, left leg. Then V1 is placed approximately in the fourth intercostal space, slightly right to the sternum. V2 is opposite side of the sternum. V3, then we place V4 in fifth intercostal space along the mid-clavicular line, and we place V3 between V2 and V3. Similarly, in anterior axillary line, as here you can see, we place V5, and then in mid-axillary line, we place V6. Okay, so now this is the concept which I am going to try to teach you today. Hexaaxial system of an ECG, right? So whenever you see an ECG, consider them like a camera, okay? Okay, I don't know how to draw a camera. I don't know how. Okay, let's assume this is a camera, okay? So all these leads which I previously shown you, they see our heart from different angles. Lead 1 sees our heart from here to here. So what exactly is an ECG lead? It is basically a galvanometer, okay? So how does it work? You must have seen with your electrician that there is a galvanometer. It has a negative electrode and a positive electrode. So what he does is that when he connects negative and positive electrodes, and if the current is passing through it, what will happen? It will show on this, right? So here you go. This is the negative electrode, and this is the positive electrode of lead 2, lead 1, and lead 3. Okay, negative electrode, positive electrode. And on the right leg, it's neutral. So these limb leads, lead 1, lead 2, and lead 3, they are basically 3 cameras which are looking at heart from different sides and different angles. Lead 1 is looking from right arm to left arm. If we think here is heart somewhere, it is looking from here to here. Then lead 2 is looking along the axis of heart, and then lead 3 is looking from the other side. They form einthovens triangle, as it is already shown in the figure. It's pretty messed up. I hope you understand. Okay. Now second is augmented leads, AVR, AVL, and AVF. How do these work? You must be saying, okay, in case of lead 1, as we've shown already, in case of lead 1, right arm was negative and left arm was positive. Understood? Similarly, for lead 2, right arm was negative and left leg was positive. And in lead 3, left arm was negative and left leg was positive. These augmented lead system work, right? So in case of augmented lead systems, they utilize a central negative terminal. Heart is considered to be negative, and same lead which we placed on right arm, which acted as negative of lead 1, works as a positive electrode in this case, with a central negative one, okay? This is negative, and then all these are positive, AVL, AVF, and AVR. These are called augmented leads, and their axis is minus 30, as you can see. Okay, the concept of minus 30 and plus 20 is that this is considered to be a complete triangle with 0 here, and positive to this side, negative to this side. Understood? So this is P, then 180, this is 120, which is the axis of AR, then this is 180 to 70, and this is 360 or 0 again. Understood? Okay, so now after we've seen all these, we have just drawn imaginary lines, and like I shown you in the circle previously, this is the same circle. This shows leads 1. Then as I told you that its direction is from right arm to left arm, so this is lead 1, right? Then how was lead 2? Lead 2 was from right arm to left leg. So if you can see, this is lead 2. Okay. Then lead 3 is this one, which is right here on 120. AVR minus 150, AVL minus 30, and AVF minus 90. These are just shown, right? These do not represent any leads. They are just to enable you to understand. Now we move on to precordial leads. So as I told you already that they act as cameras, right? So we already discussed in placement of leads that V1 is on the left side of sternum and V2 is on the right side of sternum. Similarly, V3, 5 is shown here, and V5 and V6 is placed here, right? So these study our heart in a coronal section. They see our heart from front, right? As you can see, it is already depicted in the picture that they see our heart from here. Okay, lead 1 is seeing from here, lead 2 is seeing from here, V3 is seeing from here, V4 from. Okay, why am I saying this? That it is seeing that this particular lead is seeing the heart from here. It is because when I'll try to make you understand how does an ECG lead works, that will come in handy, right? For starters, I'll tell you that if this is an ECG lead, let's say this is lead 1, okay, with negative terminal on right arm and positive on left arm, right? So this is lead 1. If in our heart current is moving along this line, how will it see? It will see it as this wave. When the current moves from negative towards the positive, it goes, let's assume here is our heart. Okay, this thing right here is our heart. So when current is running along this line, it will show a positive deflection, and when it is going away, it will show a negative deflection. Okay, now coming on to ECG paper. ECG paper is composed like this. It has big blocks and it has small boxes, right? In the big box, there are 5 into 5 small boxes, and each small box on vertical side represents, this is vertical side, it represents 1 millivolt, right? And on this axis, it is time and voltage. Same voltage which I told you is recorded. If it is going towards the lead, it will be recorded positive. If it is going away from the lead, it will be recorded negative, right? I told you already. Here is an ECG paper. Okay, as I told you already, one small scale is 0.1 millivolt on this scale, vertical axis. One large scale, okay, this was 0.1, so 1 would be 5 mm or 0.5 millivolt. And similarly, 2 would be 1 millivolt. On horizontal axis, you need to understand that in a standard we set the setting to 25 millimeter per second. And this is 1 millimeter, this one small box, okay, this one small box which I am trying to highlight is, this one small box is 1 millimeter. So if it 1 millimeter in a second, it means that there will be 25 small boxes, okay, 1, 2, 3, 4, up to 25 small boxes, and 5 large boxes, okay, this 1, 2, 3, 4, and 5. If we see 5 boxes, it will show a recording of 1 second on this axis. So according to that, one small box would be 0.04 second, one large box would be, this one, would be 0.2 second, and 5 large scales would be 1 second, as I told you, 1, 2, 3, 4, 5, this is 1 second recording. Okay, now that we have understood the placement of leads, now we can, I would like to tell you that which lead sees the heart from which side, and if there is some problem in any of leads, how to interpret it, okay? So, first of all, lead 2, 3, and AVF, right? Lead 2, 3, and AVF. Lead 2, right? Then lead 3, and lead AVF. These all read our heart from below, right? 2, 3, AVF. These are also called inferior leads. So if there is an MI change in these leads, it will be an inferior wall MI. Similarly, we have seen that V1 and V2 is placed over sternum, which approximately correspond to the septal area of the heart. So they are called septal leads. V3, V4, they are placed in between 4th and 5th like intercostal spaces, and they see the heart from anterior side, so they are called anterior leads. Similarly, V5 and V6 were anterior and mid-axillary line, so they are called lateral leads. Similarly, 1 sees our heart from here. Okay, this is 1, right? It is represented usually like this. So this is lead 1 and lead AVL, right? AVL. They are called high lateral. Okay, coming on just to show the same things. This is normal representation and normal waves of an ECG. This is the same ECG paper. One small box corresponds to 0.04 seconds. Okay, and like one large box corresponds to 0.2 seconds. This one small means 0.1 millivolt, right? Okay, this is normal ECG with this showing P wave. First downward deflection is Q wave. First upward deflection is R wave, and this one is S wave, right? This one is ST segment. Remember, segment does not involve any wave. This is PR interval. It starts from start of P wave to this part, right? So it involves a wave. So it is a PR interval. And here it is segment. So that is the difference between a segment and interval. Segment does not involve any wave. And as you can see here, PR interval involves a P wave. So it is interval. This is QRS complex. As I told you, this is Q, this is R, and this is S. QRS complex. This is T wave, and this is U wave. And this is QT interval, which starts from here at the start of Q wave to the end of T wave. This is small U wave. It is normally not present in the ECG, right?